Okay. Okay, I say, okay. We are live on Twitch. And now we wait for YouTube. Just a little second more. Alright, good morning, everybody. I'm Alex. This is the return of Handmade Game Dev from my 3-week absence. I've been quite a ways away on my travels here, as you can tell, away from my razor anyway. But if you would like to join me on this wonderful return, all you need for that is your drink of choice. I've got my matcha. So glad to be out of coffee country and back into my own home where I can drink all the tea I want. And we will all take a little sip of that together. Okay. There's a bug. I think I got it. Alright, so if you'll notice, we are still on Mac right now. Oh, something awful is happening. I don't know if that's detectable. Oh my god, the display is like flickering anytime I scroll. I've actually had this happen like once before. I don't know how monitors get away with just having so many stupid problems. It's still doing it. Okay, maybe it's Wes' term. Let's see. Okay. Alright, it's just Wes' term. Crisis averted, everyone. So you may notice we're still on Mac here. We're still in Objective-C land, but over my journey, my travels, many many plane rides worth of coding, I got this to work. Which I have to type in my password. I got this to work. Aha! And if you'll notice here, hey, it's our game with the little spaceship. It's loading, it's accepting keyboard input, it's running at 180 frames per second. It's pretty cool. With all of the metal GPU debugging. And for some reason, right now, there's supposed to be like a planet in this level that we're falling onto. And I don't know where it is. That's one of the things we're going to be working on today is unraveling that mystery. But yeah, this is it. This is the Mac version of my game, the Mac port, and it pretty much does all of the things that I wanted it to do, to be able to do our game design prototyping, to get things to work. We have a fully functioning Metal 3 rendering layer. We have the ability to go in and get our keyboard I/O, and everything's kind of mapped correctly now. We have, we're loading our sprite sheet from the Mac file system, displaying it correctly with metal onto here as a textured quad. Loading fonts. We have all of... Oh no. How can you not see that? Oh no. Okay, now you can see that. Okay. Okay. Embarrassing. But yeah, no, it just works. Well, not just works. This is the result of I checked back in the commit log, about a month's worth of effort to do this, and I think probably the most of that month, was spent wrestling with the fact that I haven't actually done adding a platform layer before to to this sort of game engine. So there were a lot of things that did need to get changed, as you may know if you've been keeping up with the stream. We basically had to rewrite most of like how the engine and OS kind of interoperate, and rethink a lot of that model. There were a whole bunch of things with the render API that had to learn. Oh, look! Hey, there it is. There's the planet. So we're just approaching really slowly, I guess, but we we found it. There it is. Well, that's kind of cool. Let's help. Can I help that along? Yeah. You may notice that it's like a little funky looking right now. The real thing we're doing today is there are some major changes that I wanted to make to the physics system. That okay, good. It still collides. I'm actually a little suspicious if this is the correct planet entity, or if this is no, I think that is the planet. That looks about the right size, because there also is an invisible sun entity in this level too. At least I'm pretty sure it's invisible. It may just be. I may have just left it zero mass, but it is a little weird. We have so much momentum going on here. Anyway, we'll be figuring that out in a bit. But the bulk of the work was just the fact that you didn't really have a concrete version of understanding what things should or should not be owned by the operating system versus our core game logic. Having to learn a whole new render API and programming language and interoperate with all the Objective-C stuff, as well as just like all that the little crap of like getting the dev environment that I wanted working on Mac, which we have here. We've got Xcode running as the debugger with all of our stuff that we want. And yeah, it took a month. I think in the future it probably would take half the time, if that. I think adding like an iOS platform layer is, just from looking around at some of the like Ted's code of how he did it, it seems like it's mostly the exact same stuff that is being used. It is, all of the it's still like a lot of like foundation and metal stuff going on, but then everything AppKit just kind of is getting traded away for UI kit, essentially. So it's just a different lib that handles all of like the base application and windowing kind of stuff, because everything is full screen exclusive, obviously on iOS. And then it would be a matter of actually taking in touch input some way, and respecting whatever aspect ratio that iOS wants us to be on. So yeah, I don't think that would take too long. I think my original estimate was a week for this. I think it actually would be possible to get something running on iOS in a week from where we are today, though. I think that actually is a lot more reasonable. For other platforms, I do think we're in a really good spot now where a lot of like the core game library is now written correctly to be able to do this stuff, to be able to go add another platform and go be able to do good work there. I think the most realistic, or like the ones that like would matter the most probably would be WebAssembly, and then Android as other platforms that matter. And in both of those, you can be writing to some flavor of OpenGL, So that would be, that would be another render API to learn, and obviously all of like the little stupid quirks. But that's I don't think as crazy a task. Um, to write like in Vulkan, I think would be a little bit take a little bit longer maybe, but not like crazy, not a crazy amount because it's at the end of the day like all of the render APIs are exposing the same hardware, so there's only so many ways they can be abstracting over what is actually going on here when we try to draw stuff to the screen, right? So we we are in a pretty good spot here with pretty good level of knowledge that will let us actually go do this thing where we can have this game run basically anywhere we want, and that's really awesome. It's really awesome, and it's fantastic experience and understanding of like what makes each of these platforms good to develop for, good to develop on, um, and what kind of considerations you should make to get like a native app that that works on here as well as possible. Oh, that's not even considering, we're like totally leaving out of the discussion like any real game consoles, but because I have never written like game console code. I have no dev kits for any game consoles, or have never been in that space. Uh, but I think, again, having gone through this exercise and then you know, maybe sometime in the future, going through it on a couple of different more of these other more open platforms, if we do Android and WASM, and then maybe like try to take a stab at Linux desktop. Oh, thank you. The return of the the view bots. Goodbye. Uh, I think that I'm not, I have no idea, but I would hope that game console uh is not going to be too crazy to would not be too crazy to try to figure out from there. Uh, but like obviously the those platforms are so much more closed off. There's likely a bunch of like weird stuff we'd have to do, and like I think like the the one thing that have not really that's like really not sophisticated at all yet, but yeah, doesn't really matter right now, is are like resource packing and loading schemes are very primitive here. It's like literally we are loading two files from like from a local directory uh to get the font and the sprite sheet, and like that's just not, that would not work if we start trying to push like crazy high res textures or a bunch of 3D assets, and let alone like an entire like levels worth of geometry or something stupid. Something that we're like there's a whole ton there that this is not even in the realm of caring about right now. So we're choosing not to care about. Anyway, the thing that we're here today to do, having completed our fun get Mac platform layer experiment, and then I had an awesome time not having to carry around my stupid Razer laptop on vacation with me. That was awesome. That was so great. Mac was so good to do to just like do dev on airplanes and hotel rooms. But we may want to switch back to the Razer now that we're here, just to get a little bit better performance for streaming and stuff. But that will take a little bit. I had to like rip open a lot of the Windows platform layer code that will need to be fixed. So we're not ready to go back on there yet. But the thing that we're here today to do is, now that we are, we do have the game running on at least two different systems. that are pretty different, and in a couple of different like display and FPS environments. From the my laptop has the Pro Motion refresh rate or whatever, so it like can clock itself up to 120 hertz. My monitor here goes up to 180. My Razer laptop, the built-in display goes up to 360. So we have all this stuff, and like it's immediately noticeable when I have a version of the game where the planet actually comes into view before like a minute and a half here, or however long it's been. It's immediately noticeable that the physics feel very different from screen to screen here, and because they are all operating at totally different FPSs. And my initial implementation of all this stuff was just using like the simple Euler integration scheme, basically, where we have like a delta time that we're advancing everything by, and that delta time was tied to the frame rate, and that was a like that made our physics highly coupled to what display with what refresh rate we were running on. And essentially, if we had a lower refresh rate display, oh, here we go, finally a touchdown. On lower refresh rate displays, we are going at longer and longer time steps, right? It's because let's say we're running at 60 frames per second, 60 hertz. Basically, every time we would come and try to do physics, we were doing it once per frame, and it would be happening every 16.67 milliseconds. So we would have like, let's say one frame, we were like right here, one frame like right here at 60 FPS, one frame we're here, and then basically gravity and our thrust and all these forces are getting applied at each of these different points, at each of these different frame intervals. And that would do basically is that would determine that would give us results that are a pretty loose approximation of kind of like this ballistic motion. So if we go, I think my thrust is like not quite strong enough for you. Something is a little screwed up here. But essentially, if we were to do like an arc around the planet to try to get into elliptical orbit, into like flower petal orbit, we would see, the gravity get applied like here and then here, and then because we're also boosting each frame, maybe you have like basically just enough boost that's being applied to take off and get into orbit from being on the surface of the planet at 60 FPS. But as soon as we went up to even on 120 on my laptop display, all of the little intervals where we're applying physics and doing all this stuff are now twice as frequent because it's tied to the frame rate. And so now think basically we're boosting only like the frame where I press the button, but gravity is getting applied on all of these additional frames in between all these gravitational forces. And so you could see immediately, I can't take off from the planet anymore, not having touched any of the parameters, not having touched any of the boost values, any of the masses or sizes of any of these things. It's just not possible because we're actually more closely approximating, the realistic physics here with as we get to a smaller and smaller time step as we're sampling more often. Because essentially what running at a lower frame rate allowed us to do is to skip half the time where gravity would have been applied and where we've been getting a down force, and because the gravitational force is a function of the distance squared. Um, the basically cheating and not and like physics not working for all of this in between time, for all this long in between time, let you build up a whole bunch of distance away from the planet, where the gravitational force was weak enough that you could escape orbit, or you could escape the gravity field here and get into orbit. And so that obviously is when we're trying to do a game about gravitational physics and trying to do it like the right way, quote unquote. That's a problem. Like that totally is wrong, and it makes it so that all of like the little tweaking and playing around with stuff that we had been doing, um, it was actually just like on the Razer laptop, like before we pivoted to doing all this Mac stuff. Basically, all of that was totally worthless, unfortunately, in terms of like actually getting toward where we want to be, because all of that fine tuning and tweaking only worked on that one specific display and render setup. And as soon as we would put it onto another computer, as soon as we put it onto this Mac, all the physics felt entirely different, and that turned into like actual gameplay code, or gameplay events were changing of what was able to happen or not, based on the physics being applied differently. And that's obviously not acceptable. It's not acceptable for this type of game. And the reason why it was like that was, for most games, like you don't really care, or physics being non-deterministic in this way, maybe like doesn't produce as many obvious results. Like if you were making like a turn-based game or something, for example, perhaps like your frame rate is going to help. Having a higher frame rate will help your input feel more responsive and make it look a little bit nicer. But you still have, I think you could manage with very discrete gameplay, gameplay states that you can like basically lock off until you're ready to go to the next one. But I mean, it is possible too. Like, hey, you're advancing through states way faster at this higher frame rate, and so you'll get like a game feel difference. But with this, with a highly physics based game, it's not just that the game feels different, but it's literally I can do things on lower frame rate that I cannot do on higher frame rate. They're literally just not possible, and they behave entirely different. So, this is going to be a prerequisite. I think a real prerequisite of like a technical thing that we have to do before we before we really commit toward doing a bunch of like design and level design type stuff. So all that being said, I'm gonna go get another thing of tea really quick. I will be right back. Should only take a couple seconds, and then we will go into what is the state of things and how we're gonna go to try to fix it. So please just bear with me for one quick second. Alright, I have returned with my golden monkey, my tea of the day today. So you may notice we've rewritten our fun to-do list a couple times. That's okay, because this to-do list is basically just purely for me and to remember what kind of stuff that I want to be doing. We're still doing a lot of technical things, but the thing that we want to be able to do at some point is have something we can give to people, or at least like a like prototype version of the idea that is executed well enough that to prove that like this like game concept is kind of worth continuing on and doing all this stuff. So we're up here on line number 5 of 87. That's fine. But there's basically like a couple of things that I want to do that are all related to like very core physics functionality here. And I would like to be able to draw somewhere on the screen where the center of gravity is for a level, because that will let me, and like also probably like what the gravity fields sort of look like around each of the entities in the level as like maybe a shader effect, because that's going to help with like designing stuff a little bit better, I think, to be able to kind of see like where the paths of everything could be. What I wanted to do is have change the way movement works when we're on the surface of a planet. So if we'll take a look here, it's gonna take fucking forever. But when we're on the surface of a planet, you're kind of just like stuck there, and the only way to move around is to like kind of boost up like at some angle and then like get yourself in orbit. It kind of feels not great. So I think what we would be good is essentially a different type of movement when you are touching the surface of, and we're going to keep everything circles for quite a while. Basically, when you have a different movement when you're on the surface of a planet that allows you to basically keep moving tangent to the planet surface wherever you're touching, so that if you hold like right, you hold D, your spaceship will like keep going like around, just like be able to like kind of walk around the planet, because that'll allow you to get to maybe the position that you want to be a lot faster, more reliably, and it'll just feel nicer than being just stuck to a surface. And at the same time, we want to be able to the boost to kind of work and feel a little bit better when you're on the planet surface, and continue playing around with what are the things that allow you to actually recharge your boost, because that is one of the biggest hurdles that we've had so far with actually designing levels and designing like a system for that works with this rule set, has been that the ability to do unlimited boost and to go so far, which is kind of one of the cool things, also lets you kind of trivialize any set of like planet levels that I could come up with. So that needs to be figured out a little bit more. But the big one today is the lock the target frame rate and simulation rate. And so there are a couple of components that go into this, like I've just described. If the frame rate and the physics are coupled together, if essentially naively you go through like your game input, then game state, then render loop, just like that, all of those things will be, all of like the feel of how the game is actually operating will be highly dependent on the frame rate, and produce all these like undeterministic results that we don't want. So the way we're trying to get around that is, we had our our like update code for the game in this metal view delegate display link needs update function here. We're calling in, and essentially, we've added a couple, like another while loop in here that allows us to kind of play around with, that allows us to now do our physics simulation a few times per render frame as opposed to always just being the same. So we're targeting essentially whenever metal hands our game loop the keys to the kingdom to do whatever, we are trying to simulate in steps of 480 hertz. And 480 is just kind of arbitrary. It's like pretty fast. This is 2 milliseconds is pretty tight, so we may need to knock it down, but we want it to be pretty fast so that we get a better feeling of physics that are better approximating the real world. As we decrease the time step, you get a better feel, but also like this is kind of our upper bound on like what displays that we are able to like kind of render at and have everything be able to sort of like work okay to at least be hitting one physics render per one physics update per render frame. But it's something that we can obviously change later. 2 milliseconds, super tight to do everything. I think we're like well under that by quite a bit right now, but our scene and our rendering situation is not very complex at all. So like the amount of work we're asking the CPU and GPU to do is only going to get it's only going to increase from here. But essentially that's like the big difference is we're getting the, instead of just like looping this once, we're going through this loop once per render frame. We're doing it multiple times here. We are finding out how much time passed between the last render frame and now still, and we're clamping the top of that so that you can debug and like if everything just goes out to lunch for a little bit, you don't end up with like the you don't end up with like a crazy big physics frame that just like blows everything up. And we'll have to figure out relativity from there. But essentially, we have this little variable here that's our accumulator, and this is where we're feeding that how much time has passed in between render frames, and then while that is still above like the sim step size 1/480, or at which is at 480 hertz, right? We are going to do all of our physics updating. Right now, all of our physics game state stuff is very tightly coupled to how we build our render quad buffer, which is not exactly the same as our vertex buffer, but that's something that like not right now, but probably would make sense to change in the future, because it's kind of like really expensive, I think, to be we're like blowing up the entire draw frame and world frame that we're creating every time, and this is a lot of matrix transforms and like data pushing around crap that we're doing we're doing here, and it is basically all wasted because the only one that actually is going to matter is the final one whenever we actually hit this condition of the the amount of time that we've accumulated is less than our physics step size. So all of those, we are like doing some percentage of the work to generate all these in between frames that like we just know is going to be completely thrown away. The world frames, I mean, this is like This also, I guess, is kind of like wasted here. Um, we have the projection in the view matrix. That's like not that much. That I'm like not nearly as concerned about. But yeah, it's something to think about. But that's pretty much how it works. Um, Other than that, it's like still kind of doing all the same stuff. All the rest of this code is unchanged. But basically, it means that theoretically our physics simulation is getting applied at 480 hertz always. Even no matter what the FPS is. And you may notice things look like hella slow right now and bad. And I'm a little suspect here. I was logging things out because I was having some problem with my time step. I was having a lot of problems with getting the time step to work and trying to figure that out in a bunch of places with no Wi-Fi, no access to the Mac docs. So I'm a little suspicious because our like string creating stuff does a bunch of like memory allocation, kind of like mid loop here and all this like baloney. If I get rid of that, if I actually get rid of this one too, if we get rid of all the logging, how much like faster does that seem? It kind of seems the same. Kind of seems the same to me. So let's see, and we were still able to render at 180 there. So let's just put that back. Well, we'll leave that for now. We have to make sure our thing we're working on here, the thing, is going to our level that we're trying to generate is going to not take forever to test stuff out. So we will put that at one planet's length away from the planet. So there we go. And you'll notice that is really frickin' slow. But it could just be too that my masses are all kind of messed up right now. No, I think that's like what it's supposed to be. That 1 times 10 to the 4th. Ten to the 24th, sorry. So that's really slow. That like should not be that slow. So why on earth? And I know it was like some thing. Like I didn't touch any of the values, and then like one commit, it just kind of started behaving like that. Really not great. So there's like some kind of problem there. I don't know. I don't know if that really explained the problem here, but there's some problem. So what have we done since that stopped working? It might be. I'm still a little suspect of my like actual time step here because the let's look. If we do like debug into this and then look at the console. So we have so many what I would expect to be happening is from this logging. What this logging is trying to do is essentially every time we update the physics, we are going to be printing one of these lines. And it tells us the start time of the game opening, the last time we checked the time, the what the new current time is, which should be like about the same. The difference between the last time and the new time is this delta t value. And this time elapsed is describing our physics, what time our physics is actually in versus the render time, right? Because the physics time should be at a slightly different point because it's traveling in those 480 hertz intervals, and the accumulator is describing basically how many from like a render point, like how far back is it. And look, yeah, the concerning thing to me here is, the very first time we grabbed it, it looks like it's at 0.25 basically, which is our hard-coded top value. But they could be, hey, just the first frame is like screwed up a little bit. But if we find the next one, it does look like it's not going up to 0.25 anymore, which is good. Like that does make it seem like it's not totally going out to lunch. But I think like the math, our math is somewhere wrong here, because it just feels so slow. It just feels so crappy. But I don't want to spend too much time like on trying to figure out if it's like something I broke, or if it's just like the way, because I think this code is closer to the way that it should be anyway. So we just have to kind of make it feel better like that. So if we're looking here, like this is so slow. It's achieving this frame rate pretty stably, and like that's another thing to be cautious of is we are not the only ones controlling this frame rate, which is a little bit of a problem. But yeah, like we're basically not moving out here. So why aren't we moving? Well, maybe we bump this up like quite a bit more, and we're still not really moving that fast. And that was adding 6 magnitudes. That was like making that like 100,000 times more massive. But our acceleration here still seems like quite freaking low. Because if you think, this is now sun level gravity at this distance. When we were at planet scale gravity, not sponsored by Planet Scale, when we were at planet scale gravity, we would expect to see something greater than 9.8, right? We were at 10 to the 24. We should see something around that ballpark, but actually a lot bigger, because our distances between the center of gravity of that planet and like the spaceship is much lower than like in the real world, where the radius of the Earth is gigantic, and so you are out on the edge of that, right? So that's like a little weird, and again, still could be the time could be wrong, or like the variables that we've chosen here, the parameters we've chosen are not going to produce a happy result right now. But I would have expected, again, bumping it up 100,000 times to be a little bit different. As well as bumping this up, the mass of the player up 100,000 times. I would have expected something to move a little bit faster. So what gives? What is the dealio? Because we know all that is correct, basically. So I'm like, I think we really need to go in and take a look around. I'm so suspicious of the time that I want to go in here and make sure that that is right. So we will ask our friend Mr. Grok if this keyboard will work. How to get OS time on Mac. C. And I think it's going to look like, you know, this kind of what we have here, this Mach H absolute time. But this this header exposes like a number of other things too, like this continuous time, which an approximate time. So I'm not quite sure which one we want. You know, there's all this time-based stuff too, which is a little bit of a problem. But we suspect that like the CPU is not actually. We don't need to play with that on an ARM, the Apple Silicon. Yeah, I need. Okay. So this is wall clock time. Okay, so we kind of are a little suspect of wall clock time. Current media time. Current media time seems kind of reasonable. I have to go to the bathroom real quick, but we'll come right back to this. All right, and we're back. So Yeah, we probably want we probably want this one. Take sense boot. I think that is what we want there. Um. Uh. Wait, what? 1,000,000 nanoseconds divided by a million is microsecond or is milliseconds? Uh. Yes, I suppose. I suppose it is. Um. Yes, I suppose it is. I suppose it is. So yeah, I think that's probably working. I'm a little. I can't. I haven't been able to log out this delta t value that I want though, which is kind of pissing me off. How do I do like printf double? I think it's like long float maybe. Oh, it just printf just knows to do it. All right. Because I did have a bug where I was actually I was calculating that delta t, the difference between our last frame time and our current frame time. And then I was calculating it. I was doing some like accumulator math, right? And then I was mem setting it to 0 because it was in this draw frame here. So that was totally screwing everything up, and I think that basically just had it get hard coded to this 0.25 value. But I haven't been able to like log this out. It's just always been. Oh, actually, this one had it working, right? Because it's like kind of always 0. It's kind of always 0, which is like not quite right. And this is like all of this stuff is a little confusing because all these names are weird. We're going off of a couple of different resources here. So there's this fantastic blog called Gaffer on Games. It's like Glenn Fiedler's blog, where he has this great post on how to fix your time step and how to do this kind of thing. So that's kind of what we are doing is this code right here, basically. And then, but he has this last part where where for the purposes of rendering, he has he's doing some like interpolating between if you think your physics steps, if they're not if you're not a consistent rendering FPS, your physics step simulations are not going to be at like precise frame boundaries. So what you should be drawing is actually in between two game states. So you like actually have a real one. You have two real ones that you generated. You did like one into the future. Then you interpolate the animation, all the positions in between those two, which is one of the techniques for doing that. We're also going off of like John Blow deterministic. I watched this lecture that John gave like maybe 3 times. What is it called? It's like John Blow decoupling. All right, we'll just have to look on YouTube. All this to avoid showing you my embarrassing YouTube homepage. So embarrassing, so embarrassing. It was this video on here, this frame rate independence video.
It's much bigger than
I had this one downloaded on the plane, and we were going through it a couple of times. But essentially, you know, like hit the resolution that he went with, and this is for Braid, which is a class of game, or Braid is a game that has some pretty locked down physics, because it is a puzzle game that also does a lot of, like, you know, it's just like platformer physics, you would think, but it has to do all this time rewind and fast forward stuff, and then there are a couple of the worlds where things move at there's like some relativity stuff where you, like, you know, at the high gravity field in world 6 or whatever, things move slower, faster, and then, you know, there's the world 4 where, like, the time amount that you're moving is based on the player movement. So, like, this is like a guy who did a working example of how this goes in a game where this mattered a great deal and needed to could not just rely on the simple case, which is you know, where we are. We can't really be on the simple case here, because one thing that we may want to do with gravity is have relativistic motion, right? Of if you're in high gravity, you're moving faster or slower in time than everything else. And also, you know, hey, we want our ability to just, you know, get into orbit to work correctly, and the motions of the planets to all be nice and all this stuff. So we very much want that to just work. If you'll notice, here's a little copy paste the Reno bug. Is actually I did this twice, because I wanted to be able to hit this accumulator condition, and have some accumulator in here, but I wanted inside this loop part to be checking the time as well, because in between physics frames I am checking the this OS update function kind of sucks, or the name kind of sucks now, but I'm checking the operating system to get all of the keyboard states. So I'm checking all of the keys so that you can get input in on not just the render frame boundaries, but also on the physics frames. This may not be right. This may not be what we want. You know, this is to try to get us to the point where, you know, theoretically it will feel better if we're getting input more often from the player, but you know, like, maybe it's a little weird that it's a little weird that we're getting it on more than just like the frames that they can see, but oh well. But that's like, I don't know per platform if that takes a significant amount of time to go check or not is the problem, and so we just have to do that, and that's why I wanted to, like, actually get our timestamp after that has all happened, if that makes sense. But that's why there's, like, all this weird copy pasted crap here twice that, you know, probably shouldn't be. It is a little suspect. It's a little suspect, but oh well. But that is, you know, this is kind of like what I've been going off of, and, you know, again, hey, we're like, we are simulating something here. Oh, that's interesting. A couple things were weird about that. the bar is not rendering. It's not visible on screen when we're in that like default window size. And our momentum like boost bars are not rendering straight up and straight or at whenever they're axis aligned, which maybe means that the minimum size of the line segment primitive is just too small. Also, we're getting some really nasty like frame drops here, and I'm not. I couldn't tell you why. That is one thing we have to, I want to figure out is how to do like the real performance profiling on Mac. But that's like not great that this is like not stable in this scene here. I had some like nasty memory leaks before, but they don't seem like this memory has kind of been staying the same for whatever last 5 minutes while I've been ranting. How's it going, TL Security? I'm back, and this is the Mac version of the game. Is now pretty working, so that's awesome. We're spending some time today trying to figure out rewriting some stuff in the physics system, because up till now it's been very heavily coupled to the frame rate, and that produced a whole bunch of unexpected, not great results when I was on a couple of different displays from the one I'm normally on here, running a different frame rate. So we're trying our best to lock that down, because that being locked down is a prerequisite of actually designing levels around that. But yeah, a couple things here, like it does seem like it is cyclical of the thing going out to lunch and dropping frames, or the rendering frame rate not being able to be achieved. It is a little weird, right? So our GPU time to actually draw this scene is still so low. Again, because the scene is not complicated at all. But this like, so if we look like activity monitor it, it could be like I think we might be throttling the CPU. I think this might be so bad. No, we're using like 40% of a core, so I don't think that's a problem. OBS is using like all of our fucking resources though, or is using a whole ton. So that's always a problem, I think, when you're that's kind of always a problem when you're doing any dev or even like recording just any gameplay with like it just like really screws up all your performance calculating, unless you feed it into like another system with a capture card, which, oh my god, I so don't want to do. That sounds like such a pain in the butt to have to turn on a whole second computer every morning when I want to do this. But yeah, it doesn't look like our game is CPU throttling, at least, which is good. But then, like, what is explaining all these spikes here? I don't know. It is interesting though. Like, these seem pretty periodic. So I wonder if those line up with our physics frames. If those red spikes are, but then like it just kind of flatlines, because this I think is like in the metal HUD here is like a resource debugger. So all of these are utilization spikes, but none of them seem to be on the GPU end. And again, because like this GPU oh my god, look at that! It just like really spiked here. And again, this is just sitting here doing nothing. Doing almost nothing. So I don't know. I'm not quite sure. If we look at the log here, oh my god, the log is so big. one thing that is like constantly been like a little weird to me has been, I would expect the I would expect like us to not be seeing this many go to render logs out here, because this is logging in our game loop function when we're done, when we've gone through our physics, right? So like this loop here is while our time between render frames is greater than a physics sim step, which is at 480 hertz, which means that this game loop function, I think, is getting called at way faster than 480 hertz, by the metal view delegate, which is like kind of weird. It's a little weird, right? Because basically we are in here, right? This needs update is calling our game loop, which is doing all that stuff. And I suppose that is because I think right now I don't have this vsync. No, I do have this, like, this display link. It does have a thing that's preferring it to try to draw at like 120 FPS, but I think it might just not be able to because my monitor is not in 120 FPS mode, and I don't know if it has that available. So that's like a whole thing. So if we just set the, actually, we probably need to change that. If we set the preferred to 180, will we see like a little bit less weird performance? It's a great question. Now we still see like so many, we still see so many like render frame boundaries per physics frame. It's a little strange. I really hate that Xcode does not just auto kill my previous session when when I do a new one. It's really annoying. Yeah, I still haven't been able to get this variable to read anything, which is really annoying. And this time elapsed, again, this is in that's in physics step time. So yeah, I don't know. I don't know what to tell you. I don't know what to tell you there. I'm going to turn this off because I think, you know, this kind of experience has really taught me how just how finicky negotiating with your operating system display, or how the operating system is exposing your display is. Because like it really sucks to have that own, because basically like this is owning vsync here, and like we kind of don't want that, right? Like we would actually really like to be vsyncing. We would love a stable rendering frame rate, but it's just doing it in like some weird creepy way, and we're not like achieving it. You know, we're not there, and so what the hell? Like, so we turn that off, and like we are still at kind of like hovering around there, because this, but like it's being capped by I think this is the actual refresh rate of my monitor. So, you know, having gotten rid of that, I'm 25. Yeah, I just have that youthful glow about me, you know. Just got that youthful glow. let's see. Uh, yeah, I mean, commenting out those lines. We don't know what what actually is going to do here. We need to look it up. CA metal display, what is, because it's very possible. It's very possible like this is has some like defaults here that is trying to vsync us, because like, why aren't we system typically provides constants for choosing one factor displays maximum difference. Yes. Okay, we want to see. We want to see this promotion. So I think it does default you to the refresh rate of the monitor. It's just like, I guess is what you like want, but then like, I don't know. Games just let you monkey around with that so much. Like, let you theoretically be at unlimited. I don't know. I don't know. Like, on games where they unlimit that, what the engineering that goes into kind of making that work though. Kind of irritating. The only acceptable values are 1 and 2. Alright, well, I guess we're going to leave this. I guess this is basically doing nothing because we're telling it to the default anyway. So, oh well. But that would be something, once we actually have real complicated stuff we're trying to draw here, that we may want to detect that and like go down to a lower frame rate if the user's computer can't handle it, something like that. So let's see here. Yeah, basically all of that was to say Mac OS kind of owns calling us, which is a little weird because, hey, I think it kind of sounded like it's maybe calling us at the monitor refresh rate, but clearly it's calling us more often than that. So we must be hitting some other condition here that is not actually going through and doing all that stuff, or and drawing faster. Although I don't know, maybe it is. Because I think all of this stuff is I'm not lost in. I kind of know my code. I'm lost in the Mac the Mac OS API stuff, because it's just like a bunch of implementation details on their end that I have not played with specifically before, so I couldn't tell you. I would think maybe like yeah, because all of this like pipeline stuff is our render pipeline, and that's definitely got to be happening at render frame boundaries. So it'll be using like a stale. It would be using like a stale quad buffer if we're below, or yeah, if we're above or we're below the physics step time, because we're using the same draw frame. But I think like maybe like the way that Metal schedules what like the drawables, that theoretically would be the thing that that is going to put the the bounds on how fast this display link update is getting called. Yeah, this is what I would want to see here. Target presentation timestamp. Yes, this is what we want. Target timestamp. So that is going off of that. Yeah, this is what I want to know. This is what I actually want to know. Is how Metal is timing me here. GPU has additional time to clear running. Yes. So what is it like? What else would the GPU do? Yeah. So well, yeah, that's a little irritating. But I think that's pretty much all we can see in the doc there about maybe here. No, this is what we were just looking at. Yeah, I think all we can kind of take away really is that Metal Display Link is just going through and it's going to generate a bunch of do all our work to generate like a bunch of extra frames here that we kind of don't need to be doing, and dump that over to the GPU. And it kind of is fine while we're we're taking so little time to do any GPU work, while we're only at like what 100 microseconds worth of GPU effort. We're still like so far below like what would cause a problem, and like even when we're spiking, it's not like the amount of GPU work is very stable, or it's stable well under what we needed to do. But then like like who is causing us to not be able to achieve this frame rate? Is it just other crap running on my computer that is like getting like it's probably like we're just getting scheduled over, I would imagine. It's probably someone else like takes over and then like the scheduler has to come back. But that's freaking annoying. It's really annoying that you just like can't do that. Yeah. Because I like the amount of work like the CPU is doing, I think is quite stable, because like we certainly should be seeing like plenty of physics frames go by. Wow, because now that's going down a lot, and that is because we're asking so on like this exact setup, and this is now like we're like pretty in the freaking weeds here. Like this exact screen I'm drawing is asking Metal to do a lot more. It is asking the GPU hardware to do a lot more, because we're drawing all this like non-static text crap. Mostly if I minimize windows. Yeah, I think maybe like the GPU part of the M4 chip is just not is either maybe like context switching dependent here, or like just not parallelized enough where like even having to redraw the rest of this display is causing a problem. Because that's kind of crazy that it does it starts to produce like an inconsistent frame rate here. And like, oh yeah, okay, yeah, we're trying to draw at 180 is pretty high. Maybe we should lock it to something lower. But it actually is a good test of our at least the physics stuff that we want to be doing to be at something, or have a case here where the display frame rate is a little bit variable and fucked up. Okay, but like so we here have like, let's see, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then one physics update. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 16. Physics update. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. 2, 3, 4. Yeah, so we're at like some boundary there, and if we were to think about that, like 480 by 180, 2.67. It's what was that? So that would be like 3/8. Yeah, that's about 3/8 of that. So we like metal is calling that at such a high speed. What is the? I'm curious what the clock rate is of my CPU here. How do I find that? It's not here. It's in. Oh, I think I just closed it. I think it's in that system report thing. About system reports. How do I see the CPU? Obviously, that's not the CPU. Also, yeah, that might be a problem. Is maybe this hardware supports Metal 4 better than Metal 3? Could be an issue. Is that really the only screen where it won't just tell me what the I can't just find out easily what the clock rate of my CPU is? Come on. Come on. Ugh. Come on, Apple. Really? No, I want to see how fast it's running. Alright, on an M4, just tell me. Please. 4.46 gigahertz. Yeah, so if we're on like, and we're like all on one core here, or all our code is on one core, but when we run, there are a couple of different threads that are. There are a couple of different threads that get created. If I like pause somewhere, but most of these are like OS owned. Yeah, we have like 10 threads worth of crap here, and I think they're just all doing kernel stuff. NSFN pthread. Yeah, but what pthread? WQ thread. Work queue. Yeah, I couldn't tell you what all of these other threads are doing. It's all like OS background garbage. Uh, yeah. Well, I think the takeaway is like, okay, we cannot achieve stable 180 FPS. That's the takeaway, and I don't think we have enough control to get that to really work here. If I go tell this to do 120, will it actually park itself there? It will not. It will not, which is very annoying. Um, but I think we have to live with that for right now. So oh well. Oh well. Okay. All right. Moral of the story: the display link update is getting called pretty fast. It's getting called even 16 times faster than 480 times 16. It's getting called at that. It's like 7,000 times a second. 7,600 times a second. Which is so weird because like it's just asking us to do so much extra work to do that, to do all this like transfer to the CPU or to the GPU, and then reconstructing like the metal encoding. Uh, like we could probably implement something similar to like another accumulator thing on the render pipeline to limit that. That would be a way, actually, you know, if like that would probably be a good way to like save on if this ends up like just eating computer battery life for no reason. Like that would be like a freebie, I bet. Uh, but I think that's something we leave alone while until we get to the point where we uh, are actually sending real loads that are not just two quads to the to render in the scene, because we're like whatever we're looking at is not going to be the performance situation of a more real looking game, right? Uh, but again, okay. So all of that, we're back here. Mystery. Why is this delta t value wrong? Why is this delta t value printing out wrong? Is the question. And I still don't know. I still could not tell you. Um, and I don't know if it's actually wrong right now. I did have it be actually wrong before. But we can just double check pretty easily right now by just doing that. And excuse me. Excuse me. Load my symbols, please. Well, that's not good. It is not loading the symbols of that file. Let's kill that and try again. Hello. It's kind of amazing how finicky Xcode is to just get it to load the symbols of my damn thing versus like any Windows debugger. Oh, come on. Yeah, didn't load it again. All right, I'm going to go pee and grab some tea real quick, and I'll be right back. Okay. Yeah, so what the hell? How come my symbols are not loading on there? Will they load here? The answer was no. The answer was no. It sucks. It's literally as simple as just come on. It's like the same freaking file always, and it just won't respect that. Oh god, how do I do this again? I have to like edit the scheme or something. Yeah, that's the one. That's what we want. Why? Game.dism. Oh, that's gonna make this really pain in the butt here. I could try clean rebuilding, I suppose. Okay. Oh. Well. Oh god. That freaked me out. It was like, why is that size 0? Did we stop building symbols? Debug symbols for this? Alright. No, it's still not. What the hell? Oh, God. Alright, yeah, this is like the best reason to move back off of Mac is because Xcode really just sucks. It's like, it's the only debugger you really have, and it just is total butts. Um, no. Oh, come on. Man, that is just so irritating. Trying to just like do the thing, do my actual engineering here. Uh, and then right, let's try re-adding it to the scheme. Because I didn't touch any of the build stuff either. This is the absolute path of the up-to-date one that's getting copied in. Oh, come on. That is just the pits now, isn't it? That is just the pits. Because it's not like I don't have like some weird unsafe buffer, no. Well, well, that is pretty lame there. Pretty lame. Thank you, Xcode, for. Thank you, Xcode. Mm-mm-mm. Mm-mm. All right. Um. Hmm. Mm-mm-mm. Yeah, so this time elapsed, we're just using that for debug right now. But what it should look like is the time, it should look like that time last minus time start, basically. It should be in fixed 480 hertz intervals that are about that much. That is about the time elapse. Um, yeah, I mean, am I just doing something like really stupid here? I suppose I could be. I should get rid of this clamp for now. That's like one thing we can just simplify. Oh, that really sucks so much that I cannot debug into my game anymore right now. And for no good reason. Oh, what the hell? Oh my god, what is going on? How did I beach ball myself? Let's see here. Oh, this isn't even launching anymore. What the hell? Yeah, it's possible the UUID of that changed when I blew that up. Maybe. Um, no, it's beach balling again. Wow, what happened? Oh man, what the heck just happened? It's there, but it's not there. Crap. All right, if I launch this from directly, let's see. Oh, it's just not working completely. Oh my god, what happened? That is really concerning. Um, ooh. something really broke. And unfortunately, we're kind of out of time here. Wow. What is going on? Not responding. I mean, the only... How do I just kill it from this window? Can I not kill things from this window? Let's see. Yeah, like it didn't grab all of the memory that it usually does. Just a little weird. Yeah, force quit that guy. What the hell? I mean, the only thing I could think of is maybe that setting that display preferred display rate maybe is screwed up. It's what Xcode project stuff changed here. My bundle identifier changed? Why would that change? Why did that change indeed? No, we're still putting that in there. Okay, I guess we try removing this display thing again. Well, that's not good. Yeah. I think something is really screwed up right now. I'm really confused what the hell it could be here, but we're out of time. I gotta go hop on to the day job work. Not as fun as debugging Xcode, but we get by. So thank you very much for watching for today. Thank you very much, TL Security, for joining me live. I hope that was at least somewhat fun. And we'll be back again next week, as always, continuing down the path, building some fun stuff, and keeping at it. So take it easy, everybody. Sip your tea. Have a good